In this chapter, we're going to talk about measuring the cost of living. So we're going to think about what causes inflation or deflation, and we'll define those here in just a little bit. We've actually talked about those in a previous video, but we'll define them again. Let me give you kind of an introductory example that will help hopefully motivate why we want to talk about this. If you look at Babe Ruth's salary back in 1931, Babe Ruth earned $80,000. Playing Major League Baseball. What we want to do is think about what that would be equivalent to in modern terms, in terms of dollars now. How much would that be? And the reason we would want to do that is because it makes it look like today's baseball players are making millions of dollars, tens of millions of dollars for the best baseball players. And so it makes it look as if Babe Ruth was paid almost nothing. But we have to keep in mind that the price level has changed since then. So if we want to be able to compare 1931 dollars to dollars today, we have to make an adjustment to account for the fact that the price level has changed. So we'll think about that. We need to do some work to figure out how we're going to measure this here before we can come back to that, but we'll take a look at that here in just a little bit. We're going to use something that we call the CPI, the Consumer Price Index. Now the CPI is a price index just like the GDP deflator was. We looked at that in an earlier video. So the Consumer Price Index measures the number of dollars that a typical family has to use to buy a basket of goods. And we'll talk about what all of that means. But essentially, when the CPI rises, the typical family has to spend more dollars to maintain a constant standard of living. If the CPI goes down, the typical family can spend fewer dollars and maintain a constant standard of living. So the CPI is really just a measure of the overall cost of goods and services that the typical family or the typical consumer buys. We call that group of things that the typical consumer buys, we call that a basket of goods and services. The CPI is calculated monthly and it's reported by the Bureau of Labor Statistics, so you can go back and look at the CPI way back in time. I use the term inflation. Remember that inflation is when the overall price level is rising, and deflation is when the overall price level is falling. The inflation rate, we talked about that when we were talking about the GDP deflator. The inflation rate is the percent change there of the GDP deflator. Here, the inflation rate we can calculate is the percent change in the Consumer Price Index. Now, both of those are price indexes. They're both calculated a little bit differently, but we'll compare those. Once we've talked about how to calculate the CPI, we'll think about how the CPI and the GDP deflator, which are both price indexes, how they're similar and how they're different. So let's talk about how the CPI is calculated. So calculating the CPI, there are a few steps. The first step is to fix the basket. What that means is that we need to decide what goods are going to go into the basket. What are the goods that are purchased by the typical consumer? So the way that the Bureau of Labor Statistics does this is they survey households, they survey a number of households to figure out what the typical household purchases. And if you think about the things that you purchase, there are going to be some things that you probably would realize obviously should belong in the basket. So for example, gasoline should belong in the basket. Every family typically is going to purchase in one way or another fuel, whether it is to drive a car or maybe to heat their house. But there's going to be gasoline, some amount of fuel in the basket. There's going to be food, different types of foods. There's going to be a whole variety of things. And if you think about the goods that you consume, there may be some things that you consume that the typical consumer doesn't. And then there are going to be a lot of things that you consume that the typical consumer does consume. And so all of those goods are going to be in the basket, and the Bureau of Labor Statistics gives each one of them a weight. And those weights would add up to 100. And each particular good is going to have a very small weight. So one way that you can think about it is that the basket contains all the goods that are available. It's just that a lot of those goods have a weight that's practically zero, so they don't really factor into it. Okay? So that's the first step, is to fix the basket. We'll do some calculations here in just a little bit. We'll calculate the CPI. And in our basket, we're only going to have a small number of goods. We'll have 2 goods. But the actual basket that's used to calculate the CPI for any country would contain lots of goods. So that's the first step, is to fix the basket. The second step is to find the prices. So once we know what goods are going to be in the basket, we need to figure out the prices of those goods. And that can be an elaborate process if we're talking about the Bureau of Labor Statistics calculating the CPI, say, for the United States. So it used to be a much more labor-intensive process where the Bureau of Labor Statistics would send people out, and those people would visit stores and with a clipboard and actually record the price of bread or the price of gasoline in this town, and then they'd go to the stores in that town, and they'd go to another town and visit the stores in that town. And now it's easier. There's probably still some of that goes on, but you can find out a lot of information electronically. So the Bureau of Labor Statistics, it's still a pretty daunting task, but it's easier than it used to be. For us, it'll be easy. I'll give you the prices. So we've got an easier job than they do. The third step is to compute the cost of the basket. Compute the cost of the basket. So we need to know how much that basket of goods and services costs. So we'll just take the price times the quantity of the good in the basket multiplied by the weight. The fourth step, we're going to choose a base year and then calculate the actual index itself. So let's just say choose a base year. And then calculate the CPI. Let's talk about just briefly how to calculate the CPI. So the CPI is very easy to calculate. What we're going to do is we're going to take the cost of the basket in whatever year we're thinking about. Cost of the basket. And then we're going to divide by the cost of the basket in the base year. I'm just going to write here the base year cost. And then we're going to multiply by 100 to turn it into a price index. And then the fifth step would be to calculate the inflation rate. So let's say calculate inflation rate. And we've talked about that before. We'll do some examples, but calculating the inflation rate, once we've got the CPI, we just need to calculate the percent change in the inflation rate. The percent change in the CPI to get the inflation rate. So those are the 5 steps. Once we do an example, you'll see that no part of this is really that challenging. I've found that with my students, the challenging thing is that this process that we're going to go through is going to appear very similar to the process of calculating nominal GDP and real GDP and the GDP deflator. And that's the challenging part, is that they look so similar that sometimes it's easy to get those two things confused. So this is really something that, though no step here is going to be very challenging, it's something that you need to practice before you were to go into a test and try to do this, because it seems deceptively simple. But if you practice it a few times, it's not hard at all. So let's do a example. So let's go with first I need to give you the basket. So our first step here, I'm going to tell you what the basket is. We're going to use the same information that we used in the GDP video where we were calculating real and nominal GDP in the deflator. We're going to use the same prices for hot dogs and hamburgers that we used back then. But I need to give you the basket. So let's suppose in this simple situation that we've got, the typical consumer consumes 4 hot dogs and 2 hamburgers. So that's the basket. Now let's look at the prices that we had. Let's have here our year, and then we're going to think about the price of hot dogs, and then the price of hamburgers. And we'll use the same prices that we used in that previous example. So let's use the same years. The years really don't matter. Let's use 2001, 2002, 2003. And the prices looked like this. In 2001, a hot dog cost $1, and then in 2002 it cost $2, and in 2003 it cost $3. And our hamburger price in 2001 was $2, and then $3, and then $4. So there are the prices that we had in that previous video where we were calculating GDP. Now remember, in that previous video we also had some quantities. We had the quantity of hot dogs produced each year and the quantity of hamburgers produced each year. And we used that to calculate nominal GDP and real GDP and the GDP deflator. For what we're doing with the CPI, we don't need the quantities. So if on a test you were to be given all of this information, the years and the prices and also the quantities, then that would be more than enough information that you would need to calculate the CPI. You need the basket, but you don't need those quantities, so you would want to just ignore those. So we've got the first step, and here's our second step. We've got our prices. Our third step is to compute the cost of the basket. So let's do that. Let's just say compute cost. So we're going to do it first for 2001, 2002, 2003. So in 2001, we had 4 hot dogs. The typical consumer consumed 4 hot dogs at $1 a piece. So that's a quantity of 4 times a price of 1, plus 2 hamburgers at a price of $2 each. So that's 4 plus 4, that's $8. The basket cost $8 in 2001. In 2002, we're going to use the same quantities from our basket, and then we're going to use the prices from 2002. So we've got 4 hot dogs now at $2 a piece, plus 2 hamburgers now at $3 a piece. So that's 8 plus 6, that's $14. The basket cost $14 in 2002. 2003, we've got 4 hot dogs now times $3 each, plus 2 hamburgers times $4 each. That's 8 plus 12, that's 20. So now we've figured out the cost of the basket in all 3 years. Now what we need to do, our fourth step, is to choose a base year and then calculate the CPI. So let's make our base year 2001. We could choose any of these years for the base year. Let's say our base year is equal to 2001. So now let's calculate our CPI 2001, 2002, 2003. Make sure in 2001, our CPI is going to be the cost of the basket in 2001, which is $8, divided by the cost of the basket in the base year. 2001 is our base year, so it's going to be 8 divided by 8, then we're going to multiply by 100. That 100 is multiplied by this whole ratio. I'm not multiplying the denominator by 100, so don't be confused by that. So that's going to be 8 over 8, 1, multiplied by 100, which is equal to 100. And so we're seeing something here that we also saw with the GDP deflator, and that is that the price index is always going to be 100 in the base year. In 2002, the cost of the basket is $14, so it's going to be 14 divided by the cost of the basket in the base year, which is 8. 14 divided by 8, we're going to multiply that whole fraction by 100, and that's going to give us a price index of 175. The CPI is 175 in 2002. In 2003, the cost of the basket is $20. So it's going to be 20 divided by the cost in the base year, which is still 8. We multiply that whole thing by 100, and that gives us a CPI in 2002 of 250. So now we've got the CPI. Okay, so this is just a price index, just like that GDP deflator. Let's now figure out the inflation rate. So let's move step 5 up here. So step 5, we'll say inflation rate. Now we're going to be thinking about the inflation rate from one year to the next. So we can calculate the inflation rate from 2001 to 2002. Let's do that. 2001 to 2002. Now there are two ways we can do it. We can use that trick that we saw with the GDP deflator, where if the first year is the base year, all you have to do is look at how much the CPI changed. It changed by 75. It went up by 75. So that's 75% inflation from 2001 to 2002. But let's calculate it using by figuring out the percent change in the CPI. So we look at where the change in CPI. So it's the 2002 CPI minus 2001. So it's going to be 175 minus 100. We divide by where it started, which is 100, and then we multiply by 100. That's going to give us 75% inflation from 2001 to 2002. So that's how we calculate the percent change in the CPI. The trick here, obviously, is that this 100 and this 100 cancel out, and as long as that first year is the base year, you just have to look at how much that changed by. Let's do it for 2002 to 2003. So it's going to be 250 minus 175. That's how much it changed by. We divide by where it started, which is 175, and we multiply by 100. That gives us 43% inflation from 2002 to 2003. So it would be nice if we could always just look at how much this changed by. From 2002 to 2003, this goes up by 75, but that's only 43% inflation. So what I always tell my students is that if you're not sure when to use the trick of just looking at how much this changed by, if you're not sure, just always do this. If we were interested, say, in 2001 to 2003, then, since our first year is the base year, then we can just use the trick. We can just look at how much this changed by. It changed by 150. So from 2001 to 2003, there was 150% inflation. Okay? But again, when you first start out doing it, let's write that. When you first start out doing it, I always recommend that students calculate the percent change. Just get used to doing that until you get comfortable with it. So that's how the CPI is calculated. And again, you can see that none of these steps are that hard. The problem is that you have to remember how each step needs to look, how each thing needs to be calculated. The The Bureau of Labor Statistics also calculates, besides the consumer price index, they also calculate a producer price index. And the producer price index uses the same steps, except the basket for the producer price index, the basket contains the things that producers purchase. So there would be things like labor and raw materials, and it is designed to tell us something about how prices change for producers. Okay? In our class, we're going to be focused on the consumer price index, but they're calculated pretty much the same. So what we need to do is clear this off, and then we'll take a look at some of the problems that we have with the CPI. Let's talk now about some of the shortcomings of the CPI. As I've said a couple of times, the CPI is designed to measure changes in the cost of living, but there are a couple of biases that the CPI has. One of them is what we call the substitution bias. So let's talk about what that means just for a little bit. The substitution bias. The idea here is that prices don't increase proportionally. If the overall price level were to go up, it's not that every price goes up by the same amount. Or if the price level were to go down, it's not that every price goes down by the same amount. What happens is that some go up by more than others, and maybe some prices don't even go up at all. Maybe some prices in the economy go down. For example, electronics, that's a good where what we tend to see over time is decreases in the prices for a similar product. So it could be that some prices go up a lot, some prices go up a little, and some prices go down. Maybe they go down by a little, maybe some other prices go down by a lot. But the point there is that relative prices are changing. Now, let me give you an example that illustrates why that's important. And you may have seen something like this before. It used to be much more common. You'd see things like this on the nightly news. You might see a local news station send somebody out to run a little test where they were going to investigate which grocery store had the best prices. And so what they would do is they would visit, say, grocery store A and grocery store B. But let's say they go to grocery store A first. And what they would do is they would shop at grocery store A. They'd walk around, they'd pick some goods, and they'd put them in their basket, and then they'd go up to the register and buy that basket of goods. And then what they would do is they would take their receipt, and then they would go to grocery store B, and they would buy the exact same things that they had bought at grocery store A. And then they would compare which place it cost more at. And it was going to be store A. Turns out that if they had gone to store B first and done their shopping there, bought that basket of goods, brought the receipt to store B, and bought the same things that they had bought at store A, it would be more expensive at the second place. So I think just a second ago I said it was more expensive at A. It would be more expensive at the second one. If they started at A and then went to B, it would be more expensive at B. If they start at B and then go to A, it would be more expensive at A. But they never did that second step, right? That they would just conclude, well, we went to this store and then we went and shopped at B and it was more expensive at B. So if you want to save some money, you need to go to store A. Well, it turns out that it depends on which store you start at. In other words, it's always typically going to be more expensive at the second store. So we need to think about why is that? How can it always be more expensive at the second store? Well, here's what happens. When you go to the first store, what you do is you shop based upon what items that store has a good price on. So you're going to be attracted to the items at that store where they have relatively low prices. But when you take that receipt from store A and you go to store B, at store B you're not shopping the same way. At store B you're just buying things off of the list. And there's no guarantee that store B is going to have a good price on those. And so it's typically going to be more expensive at the second place. By the same token, if you started at store B, you would be attracted to the goods that store B has a good price on. You tend to stay away from the goods that store B doesn't have a good price on. But then when you took that receipt from store B and you went to store A, well, now you're shopping not based on prices, you're just shopping based on a list. But what we've learned in economics up to this point is that prices matter. Relative prices matter. You tend to substitute towards the goods that are relatively cheaper and away from the goods that are relatively more expensive. Now let's think about what that tells us about the CPI. So with the CPI from one year to the next, relative prices change. And so what we do as consumers is we tend to substitute away from the goods that are becoming relatively more expensive towards the goods that are becoming relatively less expensive, and yet the basket doesn't change from one year to the next. The Bureau of Labor Statistics does not change the basket frequently. So because we're using the same basket from one year to the next, the CPI overstates the amount of inflation that we're experiencing. Turns out we're not experiencing quite as much inflation as what the CPI tells us we're experiencing. And the reason is that all of us we're changing our behavior to avoid the highest relative prices. So that's a problem with the CPI. The fact that it uses a fixed basket from one year to the next, that's a problem. We'll talk here in a second about how big of a problem it is. Turns out it's not that big of a problem. It's not big enough that we need to quit using the CPI. So that substitution bias, that's the first challenge with the CPI. The second challenge is something that's similar, and that's going to be the introduction of new goods. Introduction of new goods. So when new goods are introduced, our dollars become more valuable. And that sentence can be hard for students to wrap their head around. I remember when I first heard that, I remember thinking, what? Why would the introduction of a new good make my dollars more valuable? Well, I think the easiest way to think about it is to think about what would happen if we took goods away. What if we started making lots of goods and services vanish so that there weren't as many things that you could buy, that you could spend your dollars on? Let's take that to its logical extreme. Let's just suppose that there were no goods and services that you could buy with your dollars. Then think about how useless your dollars are for you. If you're holding a dollar and there's nothing that you can exchange it for, that dollar has no use to you. You might as well burn it for heat because you can't exchange it for anything. It's only as we start introducing things that you can exchange it for that dollar becomes valuable to you. And the more things that you can exchange it for, the more valuable that dollar is. So the introduction of new goods causes your dollars to be more valuable to you, even if you don't consume the new good. Just the fact that there's another possibility for you out there to exchange that dollar for makes you better off. It makes your dollars worth more. The problem is, as we talked about with the substitution bias, the CPI uses a fixed basket from one year to the next. So if a new good is introduced, it's going to take a while before it's included into the basket. And so the CPI tends to ignore the benefit that we get from the introduction of new goods, at least until the basket is changed. Okay? So that's the second thing. The third thing that causes the CPI to overstate inflation. Both of these are causing the CPI to tell us that we're experiencing a little bit more inflation than we're actually experiencing. The third one does the same, and that is unmeasurable changes in quality. Unmeasurable changes in quality. So if you think about what happens from one year to the next, the quality of goods changes. Typically what we tend to see is that, especially with things like electronics, the quality of them goes up. So if you were to go back 10 years, the basket would have included a phone, a cell phone. But think about how much different a cell phone was 10 years ago from what it is now. The quality, what that phone can be used to do, is very different than what it used to be able to do 10 years ago, 15 years ago, especially 20 years ago. So that unmeasurable change in quality makes it hard for us to build into the CPI some adjustment that takes that into account. We have a phone in the CPI, and everybody has one, so that's going to be in the basket. But yet, as the quality of it changes over time, it's hard to somehow adjust for that. We could give it a little tiny bit more weight, but again, because the basket doesn't change frequently, we aren't able to account for changes in quality. So these three things cause the CPI to overstate inflation. And if we think about how much it tends to overstate inflation, it's not exactly obvious how much. If it was exactly obvious how much it overstated it, then we would just subtract that amount off from the inflation rate that we calculate each year. But it kind of depends on whose study you look at. The general consensus is that it's somewhere around about 0.5% per year. It tends to overstate inflation. So if the CPI were to tell us that there was 4% inflation from one year to the next, it's probably somewhere closer to 3.5%. But there's some disagreement about how accurate that number is. So we can't just subtract that off. We'll talk about why that's important here in just a second, but let me give you a hint as to why it's important. It's important because cost of living adjustments are based upon the CPI. And so if the CPI doesn't give us a completely accurate measure of how much the cost of living is changing, then cost of living adjustments are going to be off by a little bit. We'll come back to that here in a second. Let's talk now about the CPI versus the GDP deflator. So CPI versus GDP deflator. Both of them are price indexes. Both of them are 100 in the base year. We can calculate a measure of the inflation rate by calculating the percent change in the CPI or the percent change in the GDP deflator. And what we see is that most of the time they tell us the same story. But there are some times when they can be a little bit different. So remember the GDP deflator. Remember, that's based upon a calculation of GDP. It's based upon the GDP numbers that we were using. And GDP is calculated by using only the domestically produced goods and services. So this one is based upon only domestically produced goods and services. Domestically produced. So this one is going to be measuring changes in the prices of only the goods that are produced in whatever country you're talking about. If we're talking about the United States, then if the prices of goods produced in the United States is changing, that's going to be captured by the GDP deflator. But if the price of something that's produced in a different country is changing, that's not going to affect the GDP deflator. The CPI we've just seen is based upon the goods that the typical consumer consumes regardless of where they're produced. So this is based upon what people consume, what the typical consumer consumes. So the typical consumer is going to consume some goods that are produced in another country. So if the prices of those goods change, that's going to be captured in the CPI, but not in the GDP deflator. There's another difference, and that is that the CPI uses a fixed basket. But the GDP deflator is based upon the things that are produced in that time period that we're thinking about. So there's no fixed basket here for the GDP deflator. That thing can change based upon what goods and services are being currently produced. So that gives you a kind of an idea. Again, most of the time they tell us the same story, but it depends on what prices are changing. Let's talk now about how to adjust for inflation. So let's go back to that example where we talked about Babe Ruth's salary, and let's adjust that for changes in the cost of living or for inflation. So remember that what we had there was adjusting. We had Babe Ruth's salary, $80,000 in 1931. Let's think about what that would be in today's dollars. So we need the CPI in 1931. Turns out that the CPI in 1931 was equal to 15.2. Let's put these, we could put these into dollar amounts from any current time period. I've got the CPI here for 2018, so let's do that. The CPI 2018, 251.1. So we've got the dollar amount in 1931. We've got the CPI in 1931. We want to put that into 2018 dollars. So we need the CPI in 2018 to figure out how much inflation there was between 1931 and 2018. So let's think about how you're going to calculate this. So this is going to be, let's say, the salary in 2018 is going to be equal to the salary in 1931. Salary in 1931. We're going to multiply by the CPI in 2018. CPI 2018 divided by the CPI in 1931. So we've got these three numbers. We're going to plug those three numbers in there and figure out what that tells us about the salary, what Babe Ruth would earn if it were 2018. Once we do that, I'll give you an easy way to remember this. There's an easier way than what I've done right here, but this makes the calculation very easy to do. So our salary in 1931 is $80,000. The CPI in 2018 is 251.1 divided by the CPI in 1932, which is 15.2. If you do that calculation, you get $1,321,579. So this making $80,000 in 1931 is equivalent to making $1,321,000 in 2018. So you can see, now we can see whether or not the best paid baseball players are doing better now than they were in 1931, and clearly they are. The best paid Major League Baseball players are going to make way more than that. Okay? So let's think about an easier way to remember this. Let me clear the board off and then we'll talk about an easy way to do that. All right, let's think about an easier way to remember how to make this calculation. So the way I have always remembered it, I'm going to write it a little bit more generally. So let's say that the dollar amount in, let's call it year A. The dollar amount in year A divided by the CPI in year A is going to be equal to the dollar amount in year B. Let's say the dollar amount in year X. I don't want you, if I said B, it might be a little bit confusing because you might think that these years could only differ by one. So if this was 1970, that had to be 1971. So let's say year X. That way you don't think they have to be consecutive years. So the dollar amount in year A divided by the CPI in year A is going to be equal to the dollar amount in year X divided by the CPI in year X. For me, that's a much easier way to remember this because you don't have to remember which direction this thing goes. If you just remember that you've got dollar amount year A, CPI over year A is going to be equal to the dollar amount for some other year divided by the CPI in that year. And you're going to be given 3 out of the 4 things. So whatever 3 things you're given, just plug those in and solve for the other thing. So for example, I could give you the dollar amount in one year and the CPI in that year, and then the dollar amount for another year and ask you to solve for the CPI in that other year. So for me, that's an easier way to remember it. I mean, it just, you have to figure out for you what's the best way to think about it. But the key here is that you have to do this adjustment when you're thinking about dollar amounts in different time periods. You can't directly compare the dollar amount in one time period to the dollar amount in another time period. So for example, when I was in high school, a gallon of gas, I can remember there was a time in my hometown where a gallon of gas cost a little bit less than $1. And it's tempting. If I'm in a conversation with somebody and it comes up that, somehow things aren't quite as good as they used to be, it can be tempting for you to say, oh yeah, look at the price of gas now. When I was younger, you could buy a gallon of gas for around $1. Well, that's not a good comparison to make. What you have to do is you have to adjust that for changes in the cost of living because that changes from one year to the next. Technically, it's not even right to look at dollar amounts from one year to the next year without making that adjustment. Now, the amount of inflation that happens from one year to the next typically is just going to be a couple percent. Maybe in a bad year, it might be 5%, something like that. So it's not going to make that big of a difference if you're just going from 2018 to 2019. But if you're talking about very much time having passed, you definitely need to make this adjustment. Let's talk about indexation. So I alluded to this just a little bit ago, but let's talk about it a little bit more. So indexation, if a dollar amount is automatically adjusted for inflation either by law or by contract, then we say that that dollar amount is indexed. So examples of this would be things like cost of living adjustments. We typically abbreviate that COLA. A cost of living adjustment is sometimes built into a contract. So you might negotiate for a salary that has an automatic cost of living adjustment. And if that cost of living adjustment is tied to the CPI, then whatever the CPI tells us is the inflation from one year to the next, your salary would be automatically increased by that amount of inflation. You can see that that creates a problem if the CPI overstates inflation, because if it's overstating inflation, then your raise is going to be a little bit bigger than what you need to actually maintain a constant standard of living. And so we want the CPI to be as accurate as possible because sometimes it's used to index things. It's used to index Social Security benefits. It's also indexed or used to index, that should be benefits. It's also used to index income tax brackets. So again, we want it to be as accurate as possible because there are certain dollar amounts that are indexed, again, either by law or by contract. Let's talk about the difference between real and nominal interest rates. So we're talking here about adjusting dollar amounts to correct for inflation. This is really important to think about if you're talking about an interest rate. So let's think about kind of a dollar, an example that has some dollars in it, just so I can illustrate why this is important. Let's suppose you deposit $100 into a bank account that's going to earn you some interest. And let's make this easy to do mathematically. So let's suppose this is deposited into an account that's going to earn you 10% interest. That makes it easy to figure out the amount of interest. You're probably not going to find a savings account that is going to earn you 10%. But at the end of a year, you're going to have $110. The question is, are you $10 richer? Do you actually have $10 more purchasing power? You have 10% more dollars, but what we have to do is think about how the purchasing power of your dollars has changed over this year. So if there's been some inflation, then that means that each dollar that you have, you've got more dollars, but each dollar that you have buys less than it did a year ago. And so it's actually very easy to make the calculation to figure out how much your purchasing power has changed. Let's suppose here we've got a 10% increase in your income. This is what we would call your nominal income. Let's suppose there was 4% inflation. If there was 4% inflation over the course of that year, then that means your purchasing power has only gone up by 6%. So your purchasing power went up by 6%, increased by 6%. Ignore that. Remember, in a previous video we've talked about this example where let's suppose you have $100 of income and an ice cream cone costs $1. Then that means that you can buy 100 ice cream cones. Your nominal income in that example is $100. Your real income is how many ice cream cones you can buy. So we're not so much interested in just how this dollar amount changes. We need to know how much inflation, how much more or less can you actually purchase. So we have to subtract off the inflation rate from this nominal rate of return that you're earning here. Our Walmart here in town has a bank at the front of the Walmart up by the checkout stations. And there's almost always a person or two standing out in front of the bank handing out some advertisements for their savings accounts and their checking accounts. And there's always a piece of candy stapled onto this thing. This is one of the things that they hand out. I always grab one. The reason I grab one is that there's a piece of candy attached to it, and I want the piece of candy. I'm really not interested in getting a checking account, but I always feel like I need to take one and then act like I'm really reading it as I walk off, but really I just want to wait until I turn the corner, get out in the parking lot, and eat the candy. But this is the type of thing that they give you, and you can see that what this has on it is a rate of return that you can earn on some certificates of deposit that they have at that bank. And you can see that the interest rate that they show you there is 2.68%. That's what we would call a nominal interest rate. What you need to do is you need to adjust that nominal interest rate for inflation in order to get the real interest rate. So the nominal rate, let's say the nominal interest rate, this is the rate that the bank reports. This is the rate advertised by the bank. Rate advertised. What we're interested in is the real rate. So here in this example, the nominal rate is 10%. We had to make an adjustment to get the real rate. And the way that you do that is very straightforward. The real rate is going to be equal to the nominal rate minus the inflation rate. All of these are rates. The real interest rate is equal to the nominal interest rate minus the inflation rate. So in our example, the nominal rate was 10%. We subtracted off 4% inflation. That gave us a real rate of 6%. So it's going to be really important that you make that adjustment. As you save for your future, one of the things that you're going to need to do is to decide how you want to save purchasing power. And one of the ways that you're going to make that decision is based upon the rate of return of different assets that you can use to save your money. So you might buy a bond that has some rate of return. What you need to do is you need to make sure that you always think about the real rate of return. It could be, let's suppose you had a savings account that earns you 1.5%, let's say 2% interest. If your savings account earns 2% interest and you've got dollars sitting in that account, and let's suppose that there's 4% inflation, then the real rate of return is going to be negative 2%. Your real rate of return on your purchasing power sitting in that, your dollars sitting in that savings account is going to be negative 2%. You're losing 2% of your purchasing power per year. So your real rate of return can be negative if the inflation rate is bigger than the nominal rate you're earning. Sometimes in that course of having that discussion with somebody, they say, oh, well, you know what, then I'm not even going to worry about it. I'm just going to hold cash. Well, think about what the real rate of return is on cash. If we think about cash, the nominal rate of return is 0%. So your real rate is going to be 0% nominal. Subtract off the inflation rate. Let's suppose there's 4% inflation. That means the real rate of return on cash is negative 4%. So if you've got the choice between holding cash or holding your purchasing power in a savings account that's earning a nominal rate of 2%, you'd rather your purchasing power vanish slower rather than faster. So this would be the better choice if these are the only two choices you've got. Cash has a 0% nominal rate of return, so you have to keep that in mind. So that gives you an idea of how the CPI works, how you can use it to adjust dollar amounts from one time period to the next, and how you can use it to think about the real rate of return that you might earn on some asset. So I'll see you in another video.